In order for us to turn text into tokenized food items for us to display in a UI on the client side, we need to add a new NLP app. NLP stands for natural language processing, and so we're going to handle some natural language processing in the NLP app. What we'll do is we'll create a function called process text and get nutrition. This request will be a post request. So any clients who say, hey, I ate 3 ounces of chicken breast, 3 ounces of beef, etc., this will be decoded here. And once we decode our text, we can actually make a little post request within our NLP app that says, okay, process this text and tokenize all of this data. So this function is written assuming that we're able to tokenize all of the text into, we're going to get all of the ingredients from the NLP data object, and if there are none, then we just assume it's an empty list. And what we'll do is we'll iterate over all of the ingredients in our data object and append all of the food names from each ingredient. And if there is no food name, then we'll just append an empty string. We're going to create a query param that essentially adds or joins all of the ingredient names by a comma, and then we'll use our food diary app and hit the API there to get all the ingredients. And when I say all of the ingredients, I mean get all of the ingredient objects from the PostgreSQL database that has all the nutrition facts for each ingredient. And ureg is going to be an object that helps us convert from different measurement units. So if you want to go from grams to ounces, or from ounces to pounds, or pounds to milliliters, and with ureg we'll be using quantity formatters, so we can set the format of the number that we get after the conversion to 2 decimal places or 3 decimal places. I think with a conversion factor, I'd rather have 3 decimal places for precision, and for quantity, 2 decimal places is enough. I don't know any scales that have more than 2 decimal places of precision, but I digress. So the next step is to get all of the ingredients data from the response, and we're going to modify the data that comes back. The reason why we want to modify the data is that we want to actually just relay this modified data to the client so that it can display all of its data in the UI. So what I mean by modify is I want to be able to take the ingredient that was asked for. So if I said I wanted 100 grams of tilapia, but the backend in the database only has it in ounces, well, I have to take the ounces data and then convert it to grams for the client. So I need to modify this ingredient object that comes back from the PostgreSQL database and pass it down to the client in the format it expects. So all I'm really doing is copying over the ingredient data, naming it modified ingredients data, and then just setting the quantity to, and the measurement type and the measurement unit and size to the serving size and measurement type that the client expects. The distinction I want to make here is that the NLP data only has 3 properties in it. It's a dictionary with a food name, a serving size unit, and a quantity. And in the first part of this series, we were able to calculate that, and we have code in this file that handles that. But the ingredient data that comes back from the API, which essentially just hits the PostgreSQL database in our Django app, what ends up happening is that ingredient data has way more nutrition data and metadata that we can use to display to the UI. In this case, what we're doing is we're taking the values that we're getting from the NLP object, and we're taking the food name, querying against our database, finding that food name, and then getting that food exactly from the database, and then converting its default nutrition facts and serving size, which is 100 grams, and then converting from 100 grams to the desired measurement unit that was made on the client side. So if I said I wanted 5 ounces of chicken breast, but the PostgreSQL database only has 100 grams, well, we need to take 100 grams and then convert that to ounces and then do some division to get the right ratio so that when we give that value back to the client, they're able to do the conversion. And what I'm doing here is I'm actually not only passing back the correct nutrition data, but also I'm giving it the conversion factor so that on the client side, they can do some conversion math if they want to convert from ounces to grams or grams to pounds or pounds to cups, etc. The reason why I'm doing all of this on the server side instead of the client is that I want to do all of the logic that handles converting from 100 grams to the desired serving size. I want that to be limited to the server so it's done in one place and it's consistent across all platforms. That way, if you have an Android app or an iOS app, then what data you get will be the same across the platforms. You don't have to duplicate logic. So if you have a developer who's handling the Android side or the iOS side, they won't have different logic and the clients will expect the same thing. That's why I decided to do all of this logic on the back end. Of course, I can separate this out further and modularize this, but for the purposes of this experiment, I'm just putting this all in the process text and get nutrition. Of course, I can extract some logic, refactor, and make it look cleaner. The next step is to create a function called process text. And what this will do is take whatever text the client passes into the backend, like I ate 3 ounces of chicken breast and 4 slices of bread. That's what I'm going to call text. And this text will need to be converted into our NLP dictionary, which is essentially going to contain food name, quantity, and serving size unit. And so I'm going to be using the functions I created in part 1 of this series to take all of the tokens within our text and then process those tokens into foods, which are essentially just an array of dictionaries that will pass in to our process text and get nutrition. And of course, we're going to handle our errors depending on how the text value was created and formed in the JSON body. And even if you're just trying to create an app as fast as possible, don't forget to add your exception handling so that you know and you can debug more quickly when issues arise when you're trying to create your client-side app and you're wondering why you're not seeing the data you want. And I'm creating an is unit defined to help me figure out whether the unit that the client passed in to the backend is actually defined. So if I said I ate 3 slices of bread, slices is not necessarily a unit that is either mass or volume related. And so I have to do some more client-side logic there to figure out what a slice of bread maps to. Typically, a slice of bread can map to 30 grams or 35 grams of bread. So by handling those edge cases, I'm able to figure out what the best serving size and serving size factor I can use to get the right nutrition facts. The next step is to create urls.py and make sure that you import process text and get nutrition. These are the functions that we wrote in the views.py file. And we're going to name 2 paths, process_text and process_text and get nutrition. And these will just call the functions that we have in our views file. And of course, remember that in the project urls.py, you need to add the path to include the NLP app URLs that you just added in the urls.py within NLP_app. And finally, don't forget to add NLP_app to the settings.py installed apps array. Run your server and make a curl request in your terminal with the correct JSON payload, and you'll be able to see all the results. So the next step is to actually create the client-side app to hit this endpoint and see all the results.